Hi, this is Wes Simpson with another edition of the Summer Session on Media over IP, brought to you by Ames and the VSF. With me today is Kevin Salvidge, who is European Regional Development Manager from Leader. And he is going to be talking about the challenges of hybrid SDI and ST2110 for live OB production. Welcome, Kevin. How you doing today?
I'm very well, and how are you?
Oh, just fine, just fine. It's another beautiful day, although we are expecting a bit of a tropical storm. Let's see how that works out.
Well, it's summer. Can't complain.
So let's get started.
Brilliant. So, as I said, the firstly, thank you for inviting us to make this short presentation. As I said, we're going to talk about the challenges of hybrid SDI and SD2110 for live OB production. It's well documented now, the benefits of COTS, but it's the operational challenges of retaining the quality of service that we're accustomed to with SDI, especially when you end up in a hybrid IP and SDI environment, as not all manufacturers are advanced with their IP product development. Hybrid IP and SDI environments have highlighted a number of new operational and production challenges, and those include reference timing, as we now have two reference sources in a hybrid environment, camera shading, HDR production, and finally, possibly the most important, the technical analysis of both the SDI and IP signals. So let's have a look at a typical reference timing environment. And many of you in the outside broadcast will be familiar with the pictures on the right of OB trucks in compounds with satellite dishes connected to global positioning satellites that provides us with the reference timing at the remote venue. And this is critical because if you are in a live environment, the signals you are generating will be returned to a broadcast facility for maybe additional studio work, and then maybe finally to a transmission facility. And all of those have to be linked to the same reference. And that's where the GPS system is vital. So let's take a closer look. So obviously we have the global positioning satellites, and they provide us with a GPS timing signal. Then in the SDI world, we've used black and burst and now tri-level sync for our HD productions. And now we have a new reference, PTP, which is used by our SMPTE2110 infrastructure. And both of those are connected to the GPS satellite, so they're all connected or gen-locked together. But at many of the newer venues that we're now seeing sporting events take place, the OB truck compound may well be underneath the stadium, and you won't have a GPS connection, which means when you lose that, your black and burst and PTP can then start to free run. And as they're separate devices, you have a synchronization issue problem. So ideally, if the two devices were combined together, and a number of manufacturers now have products like this, although you've lost the gen lock, the black and burst and PTP will remain synchronized to each other. Now, a number of manufacturers who have a combined black and burst and PTP generator have also had a facility called stay in sync, which means although you've lost the GPS connection, the device is running at the time that the GPS had before it lost connection, and therefore you don't get such wide variations in the particular reference. So when the GPS is restored, what you don't want to happen is the device to go, GPS is back, let's synchronize everything, because this is the equivalent of throwing a rock in a pond, and the ripples will go far and wide throughout your system. And both the Black & Burst and the PTP reference devices will struggle and probably give you some kind of interruption to your quality of service as they resync. Now, a number of manufacturers have what's known as a slow sync, which means as soon as the GPS connection is restored, instead of instantly jumping, it now slowly pulls the signals back and synchronizes them with the GPS timing, which means you don't get an interruption and quality of service issues. So these are the sort of things you need to look for when you're building your trucks and you're looking at reference signals. And PTP, it is critical that that is a smooth transition back, because otherwise it will have serious implications on your production.
In fact, in some PTP monitoring systems, a sudden jump in PTP time is flagged as a error or even a malicious attack.
Yeah, it's one of the things that's been interesting, because a lot of the telco PTP manufacturers who've come to our industry are not used to losing GPS connections. They're in fixed facilities and they always have that connection. And also a lot of the telco operators are looking for a very quick resync time if Genlock is lost, which is obviously the opposite of what we're looking at in a broadcast world. So let's take a look at the operational side now and the challenges that hybrid IP and SDI brings to us. So here we have a very traditional looking OB truck. On the right hand side, you're going to see the audio area. In the middle is the main production area, where you're going to see the vision mixer, and this is where the production staff and also slow-mo replays traditionally sit. Then on the left hand side we have the engineering positions, and that's what we're going to take and have a lot more detailed look at now. So here we have the engineering positions, and the first one we're going to focus on is the camera shaders, where they have camera remotes and camera control panels. The next area, and this is quite new within trucks, is the HDR supervisor. And here you will have an engineer looking at a grade 1 reference monitor who has the ability to take control of any camera in the production. And then finally, we have the engineer in charge, who is responsible for all of the signals, whether that be SDI or IP, inside the truck, and also responsible for all the services being delivered to the clients. So let's take a look in a bit more detail now at each of those positions. So the camera shader and HDR supervisors are not interested in whether a source is IP or SDI. Over the years, they have developed measurement setups that now has to be applied in a hybrid IP and SDI environment. So when a camera shaders are using camera routing panels in SDI, they have become accustomed to an almost instantaneous switch of the SDI video sources. But in IP, the waveform monitor has to join using IGMP to each stream, and this can take slightly longer before the video is displayed. And if you're using an orchestration system with NMOS, there can be an even slightly longer delay on the transitions taking place. And in early implementations, this led to frustration that the camera shaders would become impatient. The signal's not appearing. They keep repeatedly pressing the button, and you get repeated sources flicking through, and it wasn't really good in a live production environment. So a number of OB truck operators have kind of overcome this by implementing a delay transition time to the SDI sources. So the SDI and IP source transition take the same duration. But ideally, your test and measurement waveform monitor should have the ability to be connected to multiple multicast flows, thus allowing them to switch, as we did in the SDI world, almost instantaneously. So, as a camera shader, you'll be very familiar with the view we have here of the picture, waveform, and vector display. But these are in an IP and SDI environment, as you can see highlighted here. 2 of these sources are SDI. The other 2 are IP. And as I said earlier on, the camera shader doesn't care whether it's IP or SDI. His job is to manage the color imagery and matching the cameras in the production. And here, courtesy of Game Creek Video, we have a camera shading position on board one of their 3 trucks that system integrator Icon Broadcast recently completed for them. So like camera shading, the HDR supervisor is not interested whether a source is IP or SDI. The HDR supervisor is responsible for ensuring both the high dynamic range and standard dynamic range program outputs are correct. And the HDR supervisor has the ability to access any video source and override the camera shaders, as the HDR supervisor will be viewing the source on both the highest quality grade 1 reference monitor and an HDR waveform monitor. So here we have a traditional HDR supervisor's display with the right hand half of the display showing the waveform. And as you can notice here on the left hand side of the waveform, you have the traditional IRE scale. And then on the right hand side, you have the HDR scale. Then we have the traditional vector display. And now with HDR, because with the use of wide color gamut, we also have to monitor the color space. And here we have the CIE color chart. And as you can see here, it's showing the 709 triangle for color space and also BT 2020. And then very useful below that is a false color display, which allows the operator to very quickly see where in HDR, any parts of the picture have been overexposed. On this particular case, they would appear purple. But any part of the picture that is monochrome is standard dynamic range. And any part with color is the high dynamic range component. So it allows him to see very quickly if there is an issue with the HDR service. So as I said, it's not uncommon for the HDR supervisor to have to monitor multiple HDR transfer characteristics. Customers today can ask for different variations. And in the broadcast space, we have both hybrid log gamma and PQ, along with the standard dynamic range output. And for those customers who are using Sony cameras, they may well be acquiring an S-Log3 and then converting to one of the other transfer characteristics. So this is a real challenge in a live production environment. So you need the ability to be able to monitor simultaneously 4 transfer characteristics simultaneously. And here we have a waveform display that allows you to do that. Top left display is your standard dynamic range, and that can be seen as there is no graticule on the right hand side of the waveform. The next on the top right is hybrid log gamma, and then below that we see PQ, and then bottom left is S-Log3. And again, you'll notice here that we have a mixture of SDI and IP sources. Again, the HDR supervisor doesn't care. And here we have the false color picture display set out exactly the same, with the top left for standard dynamic range, top right HLG, bottom right PQ, and bottom left is S-Log3. And again, courtesy of Game Creek Video, here we have the HDR supervisor's position on board of their trucks. And finally, the engineer in charge, who now has even more challenging environment to operate in. So not only do you have to ensure that the physical layer for both the SDI and IP signals are correct, they also have to ensure that the reference signals for both SDI and IP remain synchronized. Otherwise, quality of service issues will be experienced. And these are some of the tools that are now built into waveform monitors that allow you to monitor from a single unit, both the IP and SDI world. And here we have the IP status, and this is high level, showing you the streams that the device is connected to, and a confidence check that there is network traffic on the ports and high level error messaging. Next, we move to probably what is one of the most important, and this is the packet arrival interval time. So this is showing what the jitter is on the network and how it is affecting the streams from their destination to source. And for those using 2022-7, so you have a primary and a backup path for your stream, which is going through completely separate switches to the destination device. We have the ability to measure the path delay. And this is critical because if you lose one path, obviously you still have your program outputs. However, you're running unprotected. So this is a very useful tool if you start to have network issues that ultimately could result in a loss of signal. Then in the PTP world, the first tool that we need to monitor is the delay time. And again, here you can see the PTP sources, and you can see the traffic on both port 1 and port 2 and the frequency of the messages. And along with the delay time, the other tool we need to monitor is the timed offset, which will show us if our PTP is causing problems which could affect our program output. And also, you need to ensure that the best master log algorithm is correctly operating and that the best device to be the grand master has been selected. So again, here you can see the parameters of the best master clock algorithm, what each PTP generator is polling, and ensuring that the correct device is selected as the grand master. Many of you will be familiar with a graphic like this from the SDI world, and here we have exactly the same showing timing. In this particular case, it's PTP against a black and burst signal, and you can see on the crosshair whether the signal is leading or lagging, and you also have on the left-hand side a more detailed display in lines and pixels if there is a timing issue between your PTP and black and burst. And this can also be set up to show PTP versus RTP timing. And again, back in the analog world, black and burst signal. Is it present? Is it time correct? You need to have a device that will allow you to show this information and check it quickly. Timing comparison. Obviously, one of the benefits of ST2110 is that the video, audio, and ancillary data are individual essences, which can be routed separate of each other, but it does mean that when they come back together, you need to make sure they're correctly timed. And the timing comparison chart shows the video, audio, and ancillary data, so your RTP versus PTP timing. And obviously, one of the major challenges we've faced with ST2110 is traffic shaping and delivery. And here we have the first of the buffers, CMAX, that we can monitor for both port 1 and port 2. And the second half of this is monitoring VRX, again on port 1 and port 2. And obviously, we still need the traditional SDI status. So we're monitoring the video, embedded audio, ancillary data, and also the video quality. We also still have to monitor the jitter. And finally, the physical layer, the eye pattern. Because obviously, if this signal is not the correct amplitude, or the eye pattern is starting to close, receivers may have issues decoding the signals that you're sending them. So as I said, the engineer in charge now has even more of a challenging environment, and these tools in a single device make their job a lot easier. Before, I showed you the screens individually. Here, with a customized layout, you can now see a multitude of test and measurement tools, from the IP status right the way through to the time delay, along with the traditional measurement tools you're familiar with the vector, waveform, audio bars, phase display, timing, and picture. And these can be customized to each operator's personal preference. And again, courtesy of Game Creek, here is the engineer in charge positioned on board one of their new IP trucks. And finally, as well as providing detailed technical analysis, test and measurement products have always traditionally been used as gateway products to distribute video and audio signals. And in a hybrid IP and SDI environment, these gateway requirements have, if anything, increased. So now, not only is it a piece of test and measurement equipment that works in both SDI and IP, it can also pass through IP signals, convert them into SDI, take the ancillary data, like the VPID information, position it correctly in the SDI stream so that downstream monitors can be set up according to payload ID information. And also we have the ability to take the audio from those IP streams. So the -30 audio can now be played out on speakers locally. So as you can see, the requirements of test and measurement in a hybrid IP and SDI world are immense, but there are products out there that can cater for all these requirements.
Well, thanks for your great presentation here. I see your contact info is on the screen right now. That's very useful. Thanks for providing that. So I was interested in the one of the things that you've talked about in your experience. You know, you have a lot of productions that are both a combined SDI and IP type of environment. How prevalent is that, and do you see that changing at any time in the near future?
I mean, we still see SDI in pretty much every live production. There is some device somewhere that somebody needs. It's just the way it is.
Their lucky charm, huh? Yeah.
Yeah. I mean, it's decreasing slowly, not as quick as some people would like, but there are some legacy products out there that maybe it just doesn't fit with the manufacturer's time frame at the moment to move to IP, or it's the next generation of their product that's going to be IP. And you're in a live pressurized environment. And when things go wrong, you need to react quickly. And the last thing you want to do is think where buttons are or where options are and settings are. You almost do it from mind memory. So there are some positions that, even though there are solutions out there, have stayed that way because of operator preference. Remember, a lot of operators in this are freelance. They come in because they're trained on certain products. So they're still there. They are gradually being chipped away at. And obviously, eventually, we will get to the point where that black and burst generator is switched off and the last SDI device has been removed from the truck. But at the moment, we still have them, and they're still there in most productions.
Interesting. So also the change over to HDR is something that is pretty apparent, is going to have a big impact on not only test and measurement, but the routine operations of a lot of these OB vans. Where do you see that in the time frame right now? How advanced are we in HDR deployment?
I think it's interesting. We're in Europe. We're about to, kind of COVID permitting, start the soccer season, football for our European colleagues, rugby, and kind of a number of sporting events. And a number of broadcasters are now sort of committing that they will be offering full-time HDR services. In the past, they may have been special events like FIFA did with the World Cup, or like the Champions League final. I believe in the US you've done it with the Super Bowl. They've been one-off, like, marquee events.
Right.
But we're now seeing a drive that they want to deliver an HDR service kind of every day they do a sporting production. So we're seeing that. The big challenge that they face is that obviously the majority of the world is still watching in standard dynamic range. And that's what's paying for the truck to be there, all the people to be on the truck. That's what's making the show happen. So although the HDR sounds all new and exciting, we need to focus on it, we need to remember what's paying the bills. And as I said, the creation of this new position, the HDR supervisor, is, now seems to be well respected. Originally, there was a bit of conflict. The camera shader would set it up. Somebody would change it because they could see an HDR monitor. He'd change it back. We're now sort of educating people how this works. And I think a lot of people are actually saying that the SDR programming is now looking a lot better. Because, like when we went from SD to HD,
right,
lots of people said the standard definition programming looked better. So I think we've got some of that going on at the moment, but it's now becoming a more regular event that HDR production is taking place.
Yeah, I could see that. Every new technology takes a while to propagate, but I'm sure that they're going to be monitoring HDR and SDR video quality for quite a while to come. That's inevitable, I guess.
Yeah.
Interesting. So one last question I had. One of the things that has always been very endemic, and I've done it myself, when in the SDI environment, is looking at the eye pattern of the actual digital signal coming in. But I've never seen anybody do that in the IP domain. Is that just a quirk of people in that have long established habits of looking at eye patterns for SDI? Is that something that's really necessary, or is that something that is going to go away when people realize, hey, it's just another digital signal. As long as I'm getting bits, I'm good?
It's been interesting with the eye pattern, because obviously when we sort of had SD and then HD, I'd agree with you, people sort of got lazy about it. It sort of was just there. Then obviously kind of UHD appeared, and the first implementations, which were 4x 3G, you sort of had to, all four of them not only had to be timed, but also the eye pattern signal sort of had to be good between them. I mean, I've had clients where they've sat in their truck and they've had the phone ring from the base saying, have a look at quadrant 3. My decoder can't pick it up. I've got issues. And I won't say who they are, but then they looked and said, oh dear, the amplitude on the eye pattern's a bit low on that quadrant. I can see why they've got problems. So that sort of brought that back to life. But obviously, in the IP world, what's sort of going to take its place is the packet arrival graph. Because obviously we're now sending packets, and we, part of 2110-21, the timing and shaping, the sending device and the receiving device have to be able to understand them without either flooding one or starving it. So that's sort of yeah, it will take its place with the IP pattern, but that's going to become kind of more critical, watching that CMAX and VRX on your transmitters and
Right,
receivers.
right. Yeah, that makes a lot of sense. Yeah, it's just funny. I've never seen anybody really, put an IP signal up on a scope and check it out. It's either there or it's not there. I think, or maybe a few bit errors, but and then if it's not there, you swap it out with a different SFP and you're good to go.
Yeah, I mean, the thing I'd say with IP networks is they don't, once they're running, they don't typically drop off a cliff.
Mm-hmm.
If you're studying the interpacket arrival, the path delay, PTP, and that, what you'll see is it gradually deteriorates. Now, fortunately, most of these networks have been designed so that they can handle a level of deterioration before you lose picture.
Mm-hmm.
So that's why it's been quite interesting when we've had our units and we go in and see people after they've been installed, how they've customized the layout to see multiple IP measurement tools, all with the same timing graphic, because they're looking across the network. They're looking for what's triggered that deterioration.
Mm-hmm.
And then if they're doing their job, they can correct it before they have a quality of service issue. So it doesn't typically drop off a cliff. Yes, as you said, it can be nothing before when you're starting to rig it, and then suddenly it all appears. But once it's up and running, most of the errors we see are gradual deterioration in services. Maybe that's switches being overloaded,
Mm-hmm.
whatever's going on the network.
That makes sense. Well, very good. So thanks a lot for your time today. We really appreciate it.
Thank you, Wes.
Yeah. So, you have any big events coming up? Do you see any travel coming up in your future there, or you're gonna have to get out on the road? Maybe even just in England there?
Well, it's quite a challenge in Europe because certain countries, if I leave Britain and come back, I get 14 days where I have to isolate. So it is getting slightly better, but it is a challenge, and that's why we've had to adapt like everybody. Presentations like yourself have been fantastic. We have online services that we can offer our customers as well. We're still here.
Good.
The challenges don't go away. Our customers are still sitting at home watching television.